This is the second video in section 8.1 on multiplication properties of exponents. In this video, we'll start out with a review from the product of powers property. Keep in mind, when I'm using the product of powers property, it's important to note that I can only use this property if I have the same base. So in my first example as a review, if I have a to the power of 5 times a to the power of 4, I can simplify this by writing a to the power of 9. In the product of powers property, it states that if I'm multiplying with the same base, I add my exponents. In my next example, I have 2 to the power of 10 times 2 to the power of 4. Again, I have the same base, so when I have the same base and I'm multiplying, I add my exponents. So 2 to the 10th times 2 to the 4th can be simply written as 2 to the power of 14. If you have questions or you're not sure about the product of powers property, now would be a great time to pause the video and go back and rewatch the product of powers property video. All right, moving on. The next property is called the power of a power property. Okay, again, I want you to look for a pattern just like we did in the last video. So here you can see I have a power, x squared, being raised to another power, to the power of 4. I can write this as x squared times itself 4 times. So I can write this as x squared times x squared times x squared times x squared. So x squared to the power of 4 can be written as x squared times x squared times x squared times x squared. Now certainly we need to simplify that, and we can do that with the product of powers property that we just reviewed. So when I'm multiplying with the same base, I add my exponents. So I'm going to get x to the power of 8. And again, look for a pattern. Okay, my next example, I have a to the third power squared. So that means I take a cubed and multiply it by itself 2 times. So I can write that as a to the third power times a to the third power. Using my product of powers property, a to the third power times a to the third power can be written as a to the power of 6. Now we need to look for a pattern. How can I go from my original problem to the answer without having to write my work out? Same here. How can I go from this part to the answer without having to write my work out? Hopefully you see that the pattern is when I'm taking a power of a power, I can multiply my exponents. So in my first example, I have x squared to the power of 4. So x squared to the power of 4 is a power of a power, so I multiply my exponents. 2 times 4 is 8, so it's going to be x to the power of 8. My second example, I have a cubed squared. I can multiply my exponents to get a to the power of 6. The final property in section 8.1 is the power of a product property. Again, I want you to look for a pattern. This property looks similar to the last, except inside the parentheses, I'm going to have more than one variable or coefficient. So inside this first set of parentheses, I have a product, x times y, to the power of 5. When I'm taking a power of a product, it's similar to the distributive property, where I need to raise everything inside the set of parentheses to the power of 5. So I can simply write this as x to the 5th power times y to the 5th power. At this point, I'd look to see if I can simplify anything, and I can't. So my answer stands as x to the 5th power times y to the 5th power. You can also write this as x to the 5th, y to the 5th. My next example, I have more than two products inside my parentheses. So I have 12x squared times y to the 5th. Raise that to the power of 2. So to do this, I am going to raise everything to the power of 2. So this is 12 squared times x squared to the power of 2. We just learned that a power of a power, you multiply your exponents. So that's going to give me x to the power of 4. y to the power of 5 squared, again, with power of a power, I multiply my exponents, so it's going to give me x to the power of 10. I can simplify my answer because 12 squared can be written as 144 times x to the 4th times y to the 10th. So that's how to use the power of a product property. All right, here are 6 examples. Some of them are challenging, some of them are going to stretch you, and some of them are going to cause you to ask some questions. I'd like you to take a moment, write down all 6 problems, hit pause on this tape, and then when you have an answer for all 6, I'd like you to hit play and check your answer. So please write your answers down and hit pause. Here are the answers. If you have any questions, please or your teacher to get help.